Now, since we look for the reactions at the support, the next thing is to draw the shear force diagram quickly. So let's go. So you are going to project this line like this. You project this one downward also. Project this one downward also. Similarly, project this one downward also. So these are the three you need. You don't have to project this point load here. No. Now let's go. Now the next thing is for you to draw the shear force diagram. Very simple. Now remember that I have 10 kilonewton going upward. So I'll draw 10 kilonewton going upward like this. And this is what? This 10 kilonewton. Now, remember that assuming something like this was like something like this, where there was no force, I will have drawn a horizontal line according to that last video. But this one, you have load at each of these points. So it's all like this load is pressing down at each of these points. So this line is going to slope downward. How will it slope downward? Let me explain. Remember that what the resulting concentrated load of this UDL is 4 times 10, and that's what 40. So this one will press down this 10 40 times. So it's like I have 10 minus 40, and that will give me what? Minus 30. So this one will press it down like minus 30 times like this. So I have minus 30. So it will not be a horizontal line, to be like a line, because this thing is pressing down each of the points, so to come like this. So 10 minus 40 will give me what? Minus 30. Then after that, what will I do? The next one is for check. I have a force here like this, and that is what? 50 kilonewton. And this one is going upward. So minus 30 plus 50. What will I have? Remember it's going upward, so positive. So if I add plus 50, remember this one will give me what? 20. Minus 30 plus 50 will give me 20. So the 20 that one will go up like this. Remember this one is 10 and this one is what? 20. Okay. Then after that, remember that there was no force here at all. So you are going to have a straight line like this, a constant line, like constant something like this. Then after that, you have 20 kilonewton pressing downward. So you have 20 kilonewton pressing downward. And that's all. You can see. So this is your shear force diagram. This part is positive, this part is negative, and this part is positive. That's it. Now, the last thing for you to do is that what? Can you tell me the point where the shear force is equals to 0, which is this point? How do we get this point where the shear force is equals to 0? Now, let me assume that that point is point X. Just pay attention. Where the shear force equals to 0, I want to get this point. It's very important. Don't assume that point is half of this. That's wrong assumption. So let us do something. Remember, let me say, look at this UDL. Draw it here. Just draw it to span this section here like this. Good. Remember that what this UDL, the value we have for it is what? 10 kilonewton per meter. Now, remember, everything here is 10, all of them, we have 10 kilonewton per meter. Now, for the whole X, we give me what? 10 kilonewton per meter for X meter will give me what? 10X. And that 10X will be placed at the centroid like this. So I have a 10X. Remember, when I have 10 and 4, I have 40. Here I have a 10 and X, I have 10X. Now, note something again. Remember, if I want to get this point, this is what I'm going to do. Remember your sign convention. Whenever you cut a beam like this, for example, know that what to the left of the beam, the upward shear force are always positive and the downward shear force are always what? Negative. Take note of that. Now let's go. Let us calculate. Remember, let us try to find all the shear force at this point. Let me call this point P. Remember, shear force at P must be equal to what? 0. And let us sum up all the forces to the left. Now let's go. Remember, if I'm talking about this shear force, I want to sum up forces, whether to the right or to the left. So I'm summing up to the left. And if they are summing to the left, you must use this sign convention where upward shear force is positive, downward shear force is negative. So remember, this 10 that is there is upward shear force. So I have what? 10. This 10x is coming down, so minus 10x equal to what? 0. Why am I saying equal to 0? Because this shear force at this point that I'm calculating is equal to 0. So I have 10 equal 10x, and x is equals to what? 1 meter. So distance from here to here is what? 1 meter. It means that the remaining one here is what? 3 meter. So this is the point where the shear force is equals to what? 0. Is at what? S equals to 1 meter. And that's where you have the maximum bending moment. So that's that for that on this.